Hi, this is Mrs. Kidman, and in this video, we are going to be discussing radians and their relationship with the unit circle. Now, in previous videos, we've talked about how we can construct the unit circle and things like that. Now, we can use the degrees in a unit circle in order to find what the radians would be going all the way around the circle using that format that we have where we take the number of degrees, we divide it by 360, then we multiply it by 2 pi, and that'll tell us all those radians. And as we go around the circle, we can see that we end up with a bunch of radians. And there's actually patterns related to these radians, just like there are patterns throughout the unit circle. So we get 0 radians, pi over 6, pi over 4, pi over 3, pi over 2, 2 pi over 3, 3 pi over 4, 5 pi over 6, pi, 7 pi over 6, 5 pi over 4, 4 pi over 3, 3 pi over 2, 5 pi over 3, 7 pi over 4, 11 pi over 6, and then finally 2 pi. And we can see that all of these ones that I've highlighted in green here are actually going to be sixths of our circle here. So you can see we're going around and we've got 1, 6, 2, 6, 3, 6, 4, 6, 5, 6, 6, 6, 7, 6, 8, 6, 9, 6, 10, 6, 11, 6. In blue here, we've got all of our fourths that go around. So you can see how some of those pieces overlap there with our fourths. And then we can also see in purple here all of our thirds. And so that's kind of where our pattern lies, is we end up seeing all of our different things here. And that is a way or method that people use to memorize these. Now in this video, we're not going to talk about methods to memorize the unit circle, including the radians, the degrees, things like that. There are lots of other ways to do that. But what we're going to do is we're going to discuss how we can use these radians in the unit circle to evaluate trig functions. So we are going to do it just like we did with degrees. So if we want the sine at 3 pi over 4. Remember that on the unit circle, the cosine value is our x value, the sine value is our y value. Then our tangent values go around the circle as such. We've got the tangent of 0 here, undefined here, and remember it's going to kind of follow our pattern. Root 2 over 2 divided by root 2 over 2 gives us a 1. If we take 1/2 divided by root 3 over 2, we end up getting root 3 over 3 with simplifications. And then our last one here, that root 3 over 2 divided by 1/2 is just the square root of 3. And then we can see that it follows that pattern going all the way around the circle. So those are the tangent values. Cosine is x, sine is y. So let's go through and evaluate these. The sine at 3 pi over 4. I'm going to find 3 pi over 4 right here. I want the sine, which is the y value. So this is going to be root 2 over 2. If I want the cosine of 5 pi over 3, I would find 5 pi over 3. I would find the x value because that's the cosine, and we've got a 1/2. Now, when it comes to the negative radians, what we want to do is we want to find that coterminal angle, the one that's in the same place as that one. Now, we talked about how we can find positive or negative coterminal angles by adding to the numerator whatever that value is, whatever our denominator is, times 2. So in this case, we've got a negative 5 pi over 6. If I add 12 pi over 6 to that, we end up getting negative 5 plus 12 is 7 pi over 6. So we want to figure out what the sine at 7 pi over 6 is. So we find 7 pi over 6. The sine value is going to be negative 1/2, right? So we can do the same thing here with the cosine value. If we've got negative 3 pi over 2, I can add 4 pi over 2 to that one, and that will give us a pi over 2. And the cosine at our pi over 2 here is going to be 0. Then for our tangent values, it's going to be just like it was before, that y divided by x, or sine divided by cosine, or opposite over adjacent, but we're going to find that value. So we have 5 pi over 3. Our 5 pi over 3 is down here. It's got a positive and a negative. So it looks the same as this one, but positive and negative. So it's a negative root 3. So that makes this one a negative root 3. And then the tangent at 3 pi over 4, well, 3 pi over 4 is here. It's straight across from the root 2 over 2, root 2 over 2, which has a tangent of 1, but it's got opposite signs. So this is negative 1. So you can see how we can just use our unit circle, our tangent values, things like that, to evaluate all the way around the circle. But in this case, we're given radians rather than degrees. If you have any questions, don't hesitate to reach out. But that is how we can evaluate the unit circle when given radians rather than degrees.